Hello and welcome everyone. This video will be solving some functional problems. The first one here it is f of x is equal to x minus x squared and g of x is equal to 1 over x it says. Okay, so what is g of f of 1 over x? Okay, let us write down. F of x is equal to x minus x squared and g of x is equal to 1 over x. And then what is asked? G of f of 1 over x. This is what we are looking for. But remember here, first of all, we have to complete this inner part. F of 1 over x. First of all, what is f of x? X minus x squared. If this is y, it's going to be y minus y squared. So we can consider this 1 over x as y. So we need to replace it to find f of this thing. F of like y, you can consider 1 over x as y. So it will be g of, this will be 1 over x minus 1 over x squared. So what is 1 over x minus 1 over x squared mean? This is the same as we can apply LCM method, or by crisscross you have to do it. But it's better to use LCM method to add the to subtract these two. The LCM of x and x squared, it's going to be x squared, the least common multiple, because x squared is x times x. The least common multiple, you have to take the highest degree. And then we can take x squared as LCM, then divide x squared by x. When you divide x squared by x, x remains, times 1 will be x minus, and x squared divided by x squared, just 1, 1 times 1 will be 1 remain. So we have g of x minus 1 over x squared. We almost finished this part. And then now the next step, we need to think of what is g of x. G of x means 1 over x. This is y, it will be 1 over y. Anything take as an input for g, it will be 1 over, or the reciprocal of that. 1 over x means the reciprocal of the input. So this is going to be 1 over of, this is the whole thing, because you can consider the whole thing as y. This one as y, the whole thing. So 1 over of x minus 1 over x squared, which is, just flip it. It will be x squared over x minus 1 is going to be the answer, which is found at D. Okay, let's continue to the next question. The next question here, it says f of x is equal to 1 f of x is equal to x plus 1 over x minus 1. And the other given condition, f of a is equal to 5, means what is f of a? Replace a in place of x. So a plus 1 over a minus 1, which is equal to 5. Then crisscross, we can multiply. That means 5a minus 5 is equal to a plus 1. Let's get the a value. Then reshuffle. 5a minus a is equal to, because I brought the a here, the 5 will be shifted to the other side. 1 plus 5. So 5a minus a will be 4a, which is equal to 6. Divide both sides by 4. So the a value will be 3 over 2. You can divide and simplify. After that, is this the question what's asked? No, we are asked f of 2a. Okay, that means we need to find f of 2a. First of all, what means 2a? 2a means 2 times 3 over 2, because we got the a value, which is 3 over 2. Then you can cancel 2 by 2. So it's going to be 3. So this means f of 3. We need f of 3. So f of x already here it is defined. So replace now. In place of x3 means you need to replace every place of x3. So 3 plus 1 over 3 minus 1. So which is going to be 4 over 2. So finally the answer will be 2. This is what we are looking for. And the second question for today, the answer will be 2. Let us proceed to the next question. The next question again here, it says f of x is equal to, function f of x is equal to cube root of 1 plus e the power of negative x. So what is asked? F inverse of x. Remember the process of finding inverse. In place of f of x, write y equal to, then cube root of 1 plus e the power of negative x. Then in place of y, write x. X is equal to cube root of 1 plus e the power of negative y. interchange the place of x and y. And then our objective is to make the y unknown. For that matter, first we have to remove the cube root here. So we need to cube both sides. Cube this one, the whole thing, and cube this also. The reason, the reverse process of cube root is cubing. Then what will happen? What left here? 1 plus e the power of negative y left. The other side x cube remain. And then shift the y, the 1 to the other side again. E the power of negative y is equal to x cube minus 1. Next step, we have to take ln of both sides. Because ln means, for example, ln x is the same as logarithm of x to the base e. So if I take ln e, ln both sides, it's going to be the left hand side is going to be ln of e the power of negative y. So e the power of negative y means the negative y will come as a quotient, and ln e means it's 1. Ln e is equal to 1 because ln e means logarithm of e to the base e. So the base and the value are the same, means the logarithm value are equal, means it's going to be 1. So we can take both sides ln. So what remain here? Negative y remain. To the other side, ln of x cube minus 1 remains. But it's negative, so we need to multiply both sides by negative. So y value, or the inverse of the function, is going to be, so when you multiply both sides by negative, what left? Y remain here to the left side. To the right side, we have negative of ln of x cube minus 1. But remember one thing. Where are we now? We said y is equal to negative of ln of x cube minus 1. But this negative is going to be as an exponent we can take in case of logarithm and ln. So y is equal to ln of x cube minus 1, the whole the power of negative 1 I can write. This is the same as ln of 1 over x cube minus 1. This is f inverse of x. This is what we were looking for, and this is going to be the final answer. You can get back and check the answer. Yeah, okay, the answer is going to be A. What is the inverse? The inverse will be 1 over x cube minus 1. Okay, the last question for today. It says, which one of the following functions are one-to-one correspondence? The domain A already given to you 0 to 1, and the range, the B, is given to you 1 to 2. So when you are talking about one-to-oneness, for example, consider the function A, f of x is equal to x. This function is linear, it's 1 to 1 for every domain and range. And the second function B, it says 1 over 3 x cubed plus 1. This is also odd function. It's a kind of passing through a 1, and it's an upright and down left. Wherever the domain and the range, it's always 1 to 1. What about the third one? The third one, again C, which is y is equal to, or f of x is equal to 2x plus 1. Still, this is linear function, so it's just 1 to 1. Linear functions are always 1 to 1. Let's check for D. And when you see D, it is f of x is equal to, f of x is equal to x squared plus 1 plus 1. It is a parabola bending at 1, and it's an upward parabola. It's not 1 to 1, but the domain, look, the domain is from what? From 0 to 1, means we are going to consider in this interval only, like let us draw it from 0 until 1. And this interval, that means we need to ignore this part, this wing. Also, we need to ignore some part of it. But even if we don't have to forget the other wing, it's going to be 1 to 1. So all of them are 1 to 1 function. So if they are 1 to 1, we have to check ontoness for all. To say the one which is onto after this, it's going to be 1 to 1 correspondence. A function to say, once let me repeat it, 1 to 1 correspondence means 1 to 1 correspondence means it has to be 1 to 1 and onto both. It has to satisfy both conditions. 1 to 1ness works for all of the function here. What about ontoness? Let us check. Okay, ontoness will focus on the domain, on the range. For example, A, the function f of x is equal to x. If you take an input 0 and output, like minimum input 0 and minimum input 1, and check the result. If it is inserted 0, the outcome will be 0. If 1 inserted, the outcome will be 1. So the range will be from 0 to 1. Is this range mentioned? No. So this is not onto. It should fit. Okay, the range, okay, the outcome, like when we take 0 as an input in place of the function is f of x is equal to x. When you take 0 as an input, the output is 0. That means that this is a minimum output that you have. And when you take 1 as an input, the output will be 1. That is a maximum output for the given function f of x. That means the range of this function to be onto under this domain, it was supposed to be 0 to 1. But what is mentioned as b, 1 to 2. They are not the same. These two are not the same. So this function is not onto. A fails. Okay, let us check for the next one. The second one, b, the function f of x is equal to, it says 1 over 3 x cubed plus 1. So if we take the minimum, like if you take the minimum input 0, okay, if you substitute 0 here, what will happen? This is going to be 0 and then 1 remain. That is the minimum outcome. Okay, it fits with b. What about the maximum outcome when you insert the number 1? When you insert the number 1 in place of x here, 1 cube is 1. When 1 over 3 plus 1 will be 4 over 3. 4 over 3 means like nearly 1.3. It is not the same as 2. It should fit with the given range. It doesn't fit. That means there are numbers who are left without pre-image. So that the second function also, it fails to be onto. So it's not one-to-one correspondence. Okay, let us check the next one. Okay, when you go to C, the function f of x, as you see, it's a linear function. F of x is equal to 2x plus 1. Okay, the minimum input that we have is 0. When you put 0 in place of x, the outcome will be 1. Okay, it fits with B. Again, when you take the maximum input 1, just 2 times 1, 1 plus 2 times 1 will be 2, 2 plus 1 will be 3. So the range, it was supposed to be 1 to 3 to be onto. But what is mentioned here, the range is 1 to 2, it doesn't fit. So still it fails. It's not onto, so we cannot say it is one-to-one correspondence. All of the functions, remember, they are one-to-one. We are checking ontoness. A, B, C doesn't work. They are not onto. Again, this one fails. The last one, let's check. The last one, f of x is equal to x squared plus 1. Now, if you take the minimum input 0, already it's 1 to 1, we mentioned. If you substitute 0, the minimum input, the outcome will be 1. If you substitute the maximum output, the maximum input, that is 1, the outcome will be 2. So the range of this function on the given domain will be from 1 to 2. It fits with the given b value, with the given range. So this one is onto, and it works. It is one-to-one and onto, therefore the function d, it satisfies every condition, and we can say it is one-to-one correspondence. So these are some of the questions that I prepared for you. Thank you for watching.